Today we will be starting off with force and pressure. Now that we have around already 15 people in, I think we can start right away. So just allow me to share my screen. Are you able to view my screen?
Yes, ma'am.
Okay. Okay. So today is day 2 and we will be dealing with the second topic, that is force and pressure. As we know, the contents of the NCERT textbook are what I have noted down here. Some of you may be referring to some other textbooks by different publications. Most of them have a similar alignment of topics. So we have a force as a push or a pull, which is one of the easiest ways to demonstrate to children what is a force. And then forces are due to an interaction, and exploring the forces. A force can change state of motion. It can change the shape of an object. Then we have types of forces where we have contact force and non-contact forces with their examples. And then we move on to pressure in liquids and gases. And finally, we move on to atmospheric pressure. So that kind of encapsulates the whole chapter. And before we go into the contents of the lesson, let us have a look at what we expect our children to be able to do at the end of our teaching session. So the learning outcomes that we expect. So what will the student be able to do? That is how we generally start our learning outcomes. In fact, that's how we write down our learning outcomes whenever we have a lesson plan to make. So our students would be classifying, conducting simple experiments, explain site examples, derive a formula. So these are some of the ways in which we can frame our learning outcomes. So I have not written down the learning outcomes as to, student will be able to classify a force as a push or a pull. So instead of writing the whole sentence, I have just written the word classify. So would you please come up with a few learning outcomes for the lesson? Any one of you may, just unmute yourself and give me a few learning outcomes of this lesson.
The children will be able to differentiate the difference between the force and the pressure.
Okay, that is one thing that once we finish the whole chapter, they will be able to differentiate between force and pressure. Thank you, ma'am.
Children will be able to understand the relationship between whether it is directly or indirectly proportional with the area.
Okay,
and
so, yes, we have to introduce to them the concept of pressure is force by area, and therein they will come to understand the relationship between force and pressure. Yes, that is another learning outcome that we can expect. Any other?
They will be able to understand the types of forces. Contact, non-contact forces.
Yes, they will be able to understand the types of forces. They will be even be able to not only understand the types of forces, they will be able to give examples of these kind of forces.
Identify also.
Identify, yes, ma'am. That is another learning outcome. Any other?
Some students will understand about the application of the pressure in our day-to-day life.
Yes, that's a very important thing for us to understand, the application of pressure in our day-to-day life.
Because so many applications are there.
Yes, you are so correct. You are so correct. Because as children or even as adults, we never actually think of why a knife that has become blunt is not cutting properly, or if I'm pushing with my finger, I don't get hurt that badly.
Yes.
But if I poke with a needle, that will definitely hurt. So we can, students will be able to do that too. What about conducting experiments? Do you think our children will be able to do that once we finish off with a chapter, especially one like force and pressure?
Yes, ma'am. With available materials, we can able to perform the experiments in the class itself.
Yes. Students will be able to conduct simple experiments to understand the concepts better using materials which are easily available at home. Yes. And then they will be deriving formula, and they will also be able to solve numericals based on the formula. That is another learning outcome which I have not mentioned here, but that can be achieved. So do you think there is anything else that we can do as a part of the learning outcome from force and pressure?
They will use the force and pressure in the real life.
Yes, they will relate to force and pressure and apply it in their real life. Yes. So these are basically the learning outcomes. Any other? Okay, so we'll move on to the next slide, where I have just touched upon the methodologies that we use and how sometimes we employ the teacher-centered ones, and at many other times we use the student-centered methodologies. In case of force and pressure, it is very convenient to have a student-centered approach, because there are a lot of activities that students can do, and we can initiate a lot of conversations and discussions among the students. So unlike a teacher-centered topic, where a teacher or a method where the teacher talks more than all the students, and whatever students talk is directed at the teacher, we can involve the whole class in discussions where the students talk to one another more than the teacher talks. So we can have them working on very simple things which are available even in a classroom with push and pull. And they will, we do provide questions and we do guide them, but most of the learning is left to the students to come across on their own. So we lead them to the learning instead of giving them direct answers. And students in a student-centered method have voice and choice. Content and pace are differentiated to meet student needs and interest. So here again, like yesterday when I was talking about how we need to be more, how we need to be always aware of students' needs and interest. Needs, because the learning types in a classroom vary, and as you remember, Anuradha ma'am had spoken about it, the different styles of learning, and we do have to cater to the types of children who learn visually, who learn on hearing, who learn by doing, and the ones who learn by reading. So when we approach our lessons, we need to keep the different requirements of students in mind, so that we can reach out to all of our students in the classroom. So going on to the next slide. This is something that is just for us to remember, that activity-based learning can really help children to learn very well, especially when we are teaching concepts in physical sciences. We do apply some activity-based learning to biology lessons also, but the scope of applying activities to enhance learning is much higher in lessons like force and pressure compared to, say, respiration yesterday. even though there are activities in respiration wherein you do understand the breathing mechanism with the help of a model. But here we have very many such activities. So as Confucius very rightly in his great wisdom, he remarked that I hear and I forget, I see and I remember, I do and I understand. So we all need to, involve our students in doing as activities. Okay, and we are very, very, I think, aware, and we keep seeing this list of activities in the NCERT textbooks. And very often the activity is followed by questions. And sometimes those are open-ended questions, which we as teachers are supposed to pursue and enlighten our children. So when we come to force and pressure, before introducing force and pressure, I think that we always, or it would be easier for the students to understand force and pressure if we take them back to what learning they have already acquired in the previous classes. So in the previous class, that is in the 7th standard, they have already learned about motion. And here we need to remind them of motion and kind of, direct the topic from motion onto forces. So we can ask them, what is motion? Do you remember what is motion? And most of them, I think, will be able to tell us that it is the change of position of an object with time, or the change of location. And then we go on to ask them whether it is possible for a body to change its location or position, or whether an external agent is required to do that. So we can give them lots of examples from day-to-day life, or rather we would like to, kind of ask them to come up with examples of motion. And then we will have to introduce the concept of force, that in order to change the position or location, which is the state of motion, an external agent is required, and that external agent is the force. So a force should be there to cause a change in a position, and then that is what we call the motion. The change in the position is what we refer to as motion. So force and motion sort of go hand in hand all around us. So this is something that we can give examples by pushing something that is on wheels, or releasing hydrogen balloons because of the force upthrust, since hydrogen is lighter. Then gravity pulls everything down, which is why things fall down. And also how the motion of an object can be changed when we hit it. So these are some examples where we use motion, and we use examples of motion, and then direct them towards forces. So we'll often say that a force has been applied on a ball when it is kicked. So if we talk of motion, we also talk of rest, because that's another state of motion. So if a ball is at rest, then in order to change its location or change its position, we do need to apply a force on the ball. So whether we are kicking it or whether we are throwing it, we exert some motion, we exert a force on it, which causes a change of its motion. So therefore, we will from here go on to understand what is a force, and the entire chapter goes on to learn, where we learn and teach more about forces. So very, very broadly speaking, a lot of actions like picking something or opening something. Okay, for example, when a child opens the tiffin box during lunch, or picks up something of a rubber or an eraser or a pencil from the pencil box, or closes something, it could be just the pencil box lid. Okay, then the person kicks something, and when they are in a field, students are playing, they are kicking on the ball, they are hitting a ball, they lift things, they flick things. Sometimes we have indoor sports where carom board is a very, very nice way to talk to them about forces, because we use coins where when we flick on one of the coins, the striker goes and hits the coin, where it moves from a stationary position, it acquires some movement, and ultimately sometimes one coin may push another coin. So we can give them this kind of examples. And pushing and pulling, these are very common in the playground where children swing. So here, as you can see, a push, the easiest way to understand what a push is by telling them that a push is something that is moved away, from us. So that's a push. Whereas a pull, on the contrary, the opposite thing is when we pull something towards us. So a push and a pull. A pull is a force which moves something towards us, whereas a push is something which moves away from us. So this is a very easy way for children to understand push and pull. So a push is a force that moves an object away, and here are a host of examples. Sometimes children may playfully throw water, which is again pushing it away. You push the swing when your friend is on a swing. You can hit ball with a bat or a hockey stick. And very often children like to move the shopping cart when they go shopping. So that is another example of a push. As they enter the classroom, sometimes they would push the door. So these are all examples of pushing. And then we have pull. So pull is sometimes we can give examples of picking a flower, where I would rather have them pick it from the ground of flowers which have fallen down from the tree rather than plucking them. Fishing is an activity which involves pulling, and there are games which use magnets. I think some of you may have seen there is a fishing rod and a small magnet at the end, and then there are these plastic fishes which have another magnet near their mouth, and it's a kind of an indoor activity where children are spend their time fishing, pulling up the fish. Then opening the door, sometimes not only of doors in our rooms, when we open the door of a particular vehicle, because when children come to school in the morning, most of them come by autos or vans, where they have to pull the door open and board the vehicle. Then towing a car is also pulling it away. So sometimes we can also give them, and we can ask them to pick their bag up from the floor, because all of them have these school bags just next to them. So ask them to just move the bag up. So that's a pull. And then lower it gently. And push, we can easily teach in the classroom with pencils and erasers rather than pushing heavy objects around. Okay, so that is push and pull. And then the textbook also has a table where there are various situations where we can we can do as an activity, where children are asked to note down the kind of action that is used to carry out this particular activity. So moving a book placed on a table is something that can be done in the classroom, and it is very easy. So if you move a book on a table, it could be pushing or pulling or lifting, because a book on a table can be pushed, it can be pulled, or it can even be lifted. So sometimes when we tell children, move a book on your table, most of them usually push it away. Some of them pull it. Very few of them do that. We can ask children to do it in the class, and it is quite interesting to note how different children process the thought in a different manner, because some of them, they lift up the book. So we have these kinds of movement possible with a book, and the action can be a push or a pull, both of them. Opening or shutting a door depends on which side of the door we are. So generally in the classroom, we have a door which opens inward, and then when we close it, we have to push it. So some doors, of course, we can lift them open. and they can be lowered, especially in cabinets in our kitchen. So we can ask our children to think of kitchen cabinets where we open the door, or sometimes they are using microwave ovens or ovens in their homes. So those will have a handle where we pull them down and push it back up. So we can make them more aware of various kinds of motion in our everyday life. Then drawing a bucket of water from a well, of course, this is something that not many children have experienced in their homes, because living in cities or even in towns, most of us, I don't think, have an access to a well. Most of us have taps at home, but this can be very easily made into an activity at home, where we can ask the child to lower the mug with a string on one side onto the bucket of water. So that bucket of water, can become the well, and the mug becomes the bucket. So they understand the lifting and lowering, and the lowering of the bucket, and a pull is generated. So when we lower the bucket, we generally have to push it down and then we pull it up. A football player taking a penalty kick, I think this children can relate to very, very easily. Same with a cricket ball which is hit by a batsman. Moving a loaded cart, this we can draw upon their experience from shopping in departmental stores. So generally we have a trolley, or if they have moved their luggage across, so moving a loaded cart, or they may have seen carts being moved even on the road. And opening a drawer. Opening a drawer is generally pulling when you are opening. When we close a drawer, we use a push. When we open a drawer, we know we always pull it out. So these are activities which can be done even in the classroom. Sometimes we can ask them to do a couple of activities at home and then come back and fill the table together in the classroom after some discussion. So children get very involved in this activity and they find it interesting, because this is something they keep doing all the time, but they never think about forces coming into play. So now you can tell them that, in fact, children, we employ forces and motion in every phase of our life. And sometimes I do have children who come up with saying, Miss, I like bio more than physics, or I like chemistry more than that. So always I, kind of tell them that, children, we use physics or apply physics every moment of our lives without even realizing it. And I don't think you really don't like it. It's just that you are not aware of it. So we do need to kind of sometimes talk to children about that, so that they have a well-rounded approach to all the branches of science, especially in middle school, because till class 10 they require to learn all of the three, that is physics, chemistry and bio. Only when they go to class 11, then they are they can take a choice. After this, we come to the topic of forces are due to an interaction. So two objects must interact for a force to come into play. So here again, this entire chapter, we can teach it so easily with activities. So there is this, where children hold their hands and sometimes move in a circle. If you are, if you have enough space in the classroom, you can work it out in the class, or we can even, on maybe in 15 days, we can take them out one day and use a lot of these activities to help them understand the concepts. So an interaction of one object with another object results in a force between the two objects. So this is another thing that we can demonstrate very easily with examples in daily life or even some activities. So teachers, do you have any ideas on how you can make children understand that forces are due to an interaction? Could you give me some examples of what activities can be done? It could be very simple. Well, in the classroom, we can have children pushing one book with another, or a pencil with an eraser, or even two erasers, and then we allow them to come to the conclusion that forces are always due to an interaction. Am I audible to you, teachers?
Yes, ma'am.
Okay. Thank you for your response. And this is an
Yes, ma'am.
activity. Thank you, sir. This is another activity where we can divide the class into some groups and identify forces. Then does the situation cause a push or a pull? Does it change the state of motion? Does it change the shape? And identify the objects which are interacting for forces to come into play. So we can use magnets. We can ask children to bring magnets because some of them have magnetic toys. I remember when we were learning magnets, even in class 6, children were very enthusiastic and they got pieces of magnets even in online classes. So I think if we ask them to bring magnets, they would be more than happy to get small ones from their homes. We can always instruct them not to get bigger ones, or something which is easy and which their parents allow them to. And another thing is the plastic ruler and bits of dry paper. This is something which is so commonly done by students. Some of them would have done this even before we have asked them to, where we take a plastic ruler and rub it against our hair and hold it next to bits of paper. So the papers start jumping up to the ruler. So then we explain to them that here also there is a force. But here, interestingly, in these two, the force can be felt even when they are far away. So if you hang one of the magnets and bring another close to it, children can easily see how magnetic forces work. Then another concept which children are need to be told about is gravity. Which I think most of them by class 8, they have heard of gravity and they know about gravity. So how it pulls things towards the earth, how gravity acts on objects. And in fact, we also will have to talk to them about gravity when we come to, when we explain to them about balanced forces and unbalanced forces and how an object remains at rest. So supposing I have a surface, maybe my hand, I hope you can see, and the mouse on it. So why is it that the mouse is not flying away or falling back? So we can ask questions such as these, which will, allow them to think as to what is happening. And then we have rolling a ball, which is going and hitting other. So state of motion of the ball or the earth. These are a few activities that can be done where we divide the class in groups rather than as individual activities. A group activity always promotes some amount of interaction between the members of the group, and especially post-COVID, where children have come back to school after a long time. Many of them have, I was quite surprised when we asked some children as to whether they would like to do the activity as an individual or whether they would like to do it as a group. I was very surprised to see that, rather hear that some children opted for working alone. They did not want to work in a group. And they said that they did not, they found it difficult to interact with, other individuals. Now that is something that is quite alarming. Teachers, we as adults always understand that we cannot work on our own. We need to work in teams. And we, even at home where we live with our families, we need to have interaction with other human beings. And basically we are social animals. So this, this isolation is not a very good idea. And we need to kind of draw those kind of children who feel that they are more comfortable working on their own. We need to involve them in group activities. So even though the activity is very simple, let them be in groups of 5 at least, where they learn to even work with one another, because within members of a group, all members don't agree to the same thing. And that is when they need, so, we are actually helping them to develop interpersonal skills also. So a group activity, besides learning outcomes which we expect, it has many, it is also, there are some affective domains which are, improvised. We do involve that too. So a group activity is a very, very a nice way to bring that into play. And then we have the next topic that is there, which the textbook talks about, is exploring forces, where forces are working in the same direction and our forces are working in the opposite direction. Now, here we can also have a value added learning when we tell children that when they cooperate with one another, the sum of their efforts will always be greater than the effort that will be put in by one of them. So when we are working together, like, in the first example, if two forces act on a body in the same direction, the net force is the sum of the two forces. So here, as we can see, we also need to talk to children about how we represent a force. A force is represented by arrows. We all know that. So we need to tell that to our children, that a force is represented by an arrow, and usually a bigger force is shown with either a fatter arrow or a longer one. Okay, and here we can see F1, which is definitely smaller than F2, and pushing on an object at rest, the net force is in the same direction. Now we have to first check whether F1 and F2 are both aligned in the same direction. So both of them are pushing the object in the same direction, and therefore the effect of the forces is going to be the additive effect, where we add the two forces. So here we can again ask children to push the table, the teacher's table. We can just ask them to push it to a short distance on their own. And then we ask about two children to push it together. And then we ask the children what was the difference that they felt. In which instance did they have to apply more force? And children will be very, very quick to tell us that when there are two people working, then it is much easier to move the table. So here we also have an important learning, is that if we divide work among ourselves, the work goes down. Okay, so here, of course, it is force. Force is moving the object. And then what happens when forces act in the opposite direction? So here the net force is the difference between two forces. I'm sure we are all aware of it as adults, and we also teach it to our children. So here what we can do is again use the same teacher's table and two children on the two ends of the table and ask them to push. Now, if both of them are equally strong, then the table won't move because it becomes a balanced force. Whereas if one pushes a little more than the other, then we will be able to see in which direction the force moves, the table moves. So the effect of an object depends on the net force acting on it. And in case of forces which are in the opposite direction, then we subtract the smaller force from the larger force, and that gives us the net force. So in order to make this more, in order to apply this understanding, we can always give them a few numericals to solve. So that will definitely help our children to understand the concept better. So, we can also talk to them about the fact that a force needs to be explained both with magnitude and direction. So that is another thing that we have to talk to them about, that a force has magnitude, which is what they, in their layman's term, they will be talking about how strong the force is. So we need to tell them that the term that we are going to use here is magnitude, which gives us the amount of the force. And in case of forces, it is very, very important to include the direction. So direction of a force really matters. And if we don't give the direction, then we are giving incomplete information about the force. So we do need to convey it that a force has both magnitude and direction. Some of you may have already spoken to them about it and told them that this is these kind of quantities are called vector quantities. But generally, we can make a mention of it, but again, it is an extended learning. It is not directly in the textbook, the concept of scalar and vector. So the next concept is rather the state of motion of an object is described by its speed and the direction of motion. Children need to understand that the state of rest is considered to be also a kind of state of motion. A state of rest is considered to be the state of zero speed. This is a very, very important concept that we need to drill into our children. We need to make them understand the topic, that the state of rest is actually where a state of zero speed and an object may be at rest or in motion, and both are its state of motion. Because generally we tend to think of rest when an object is at rest, we don't consider it to be a state of motion. But an object may be at rest or in motion, they are both its state of motion. That is something we do need to know. So, teachers, can you give us give any ideas as to how you go about teaching interaction of forces in your classroom? Do you do a practical demonstration, or do you have any other methodologies, any activities?
We can explain about gravitational force also, ma'am.
Okay, about gravitation. So how do you do that, ma'am?
That while teaching, we can just make any object to fall down. And
Okay.
explain Earth is executing some force on the object.
Okay. So we teach them the concept. You can teach them the concept of gravity also with this. Okay. Any other inputs from any other person, any other teacher? Okay, thank you for your response. We'll go on with the next step, that is a force can change the state of motion. So as I was talking about just previously, that in fact we introduced the chapter with this very concept that, a change in either the speed of an object or its direction or both. Sometimes the speed and the direction changes. For example, when we are playing cricket or even badminton, we change the speed and the direction of motion of the ball or the shuttlecock, or both is described as a change in its state of motion. Thus, a force may bring about a change in the state of motion of an object. Now we have a very interesting question. Does it mean that the application of a force would always result in a change in the state of motion of an object?
No.
No. Yes. So for this also we can ask children to move something that is quite heavy. So they would realize that it is not always possible to change, or something like a wall. Even if we push on it, the wall does not move. So many a time application of the force will not result in a change in the state of motion. So this is something, again, a very core concept that they have to understand. A heavy box may not move at all, even if you apply the maximum force that you can exert. No effect of the force is observed when you try to push a wall. So these are some day-to-day examples, and also we can, you always let them understand that yes, we cannot move everything on our own, or we cannot push or lift up a lot of things, because they are the force that we apply is not enough to bring about a change in the state of motion. So that particular object may be at rest, but it is in a state of motion. Okay, so that is what we need to reiterate. Now, what are the effects of forces? Now, this is something, again, activities can make it very easy. Not only can we teach them, after teaching them or telling them about the effects, we can always ask them to give examples or draw effects of forces. So we can in fact give it as an activity and allow children to explore it on their own. As to, can you give an example of force can make a stationary body move? So most children come up with the example of a ball which was stationary and how it can move. So we can ask them to draw a picture and write the effect of the force. Force can stop a moving body, so you can apply brakes and stop a moving vehicle. We can also stop a rolling object by just keeping our hand on the path of motion. So force and applying a force. So a force can stop a moving body. A force can change the direction of a moving object. So by applying force, we can move the handle. By moving the handle, the direction of the bicycle can be changed. By moving the steering handle, the direction of the vehicle is changed. We can also move the direction of an object by applying a force. This can be seen again while we are playing. A lot of games and sports use this effect of force, where we change the direction of a moving object. For force can make a stationary body move. Again, a carom board is a very good example. And then we have children playing with tires, where they, especially in, we don't see it much in the cities, but in places where we have more space available, where children have more playgrounds and more open spaces, they take a stick and move a rotating tire. So that is another thing where force, effect of force can be seen. Then force can change the speed of a moving body. By accelerating, the speed of a running vehicle can be increased. We can also increase or decrease the speed of a moving body by applying a force, and we can allow children to give us examples. Force can change the shape and size of an object. So for this, I think one of the easiest things is ask them to bring Play-Doh or clay, modeling clay, and or even we can ask them to observe their mothers probably making rotis, where they are kneading the dough. So when we have a dough of maida or atta, that is wheat flour, and then we can change the shape and make, in fact, even design different shapes out of it. Then we can talk to them about how blocks of metals can be turned into thin sheets. So here, if they have already done the chapter on metals and non-metals, because class 8 would have, they also have metals and non-metals. We have taught them about malleability and ductility. So we know that a block of metal can be turned into a thin sheet by hammering. So that is again a change in the shape of an object. By hammering a stone, you can break it into pieces. Okay, so a lot of examples can be cited for this. Rather than we giving examples, we can ask children to give us examples, and we can ask another child to, to kind of explain the effect. So if one of them is giving the example, the other can give the effect. So in that way, we will be involving more children in the classroom and make learning more effective. Now we come to the types of forces. And I think before we go on to types of forces, teachers, there are activities which have been they have been given in the NCERT textbooks. I think we can all refer to those activities and conduct some of them in the class. We can draw the attention of children to some other examples. For example, a rubber band. A rubber band is a very nice example of a pull and when we leave it, it goes back to its own position. And sometimes we can give them an example of how when you keep books on a shelf, sometimes the shelf starts bending in the center. So that is because of, again, the effect of force over a prolonged period of time. So such kind of examples. Then the bicycle seats are attached onto the bicycle with very strong springs. So a spring also is capable of exerting force. Okay, I have an activity lined up sometime later. Just give me a moment, teachers. So here we have the effects of force. And then we gradually move on to types of forces. Now here, because we have taught them that force, when objects interact, there is a force. Okay, so here we will tell them about contact forces and non-contact forces. So contact forces, we can give examples of muscular force is one of the very easy examples, where we lift things, pull things, or put them down, or even use another stick or something to apply a force. Okay, like here we can see a person hitting the ball. So this is all basically a muscular force. Then there is spring force, drag force. Drag and friction, we have a separate chapter dedicated to it. So right now we will not go much into it. So, and the normal force, here this is something that we talk to children about when they talk of things at rest. So why things don't, if gravity is acting, why doesn't the box just go down and sink into the earth? If there is a box resting on a table, then the weight and the gravity acts on it and pulls it down. The table has an upward force, and together they balance each other and the object remains at rest. So normal force. So muscular force and friction. We can talk of friction as, with examples. We have, as I said, a detailed chapter on friction, but here we can talk to them about friction by asking them to simply rub their hands against one another. And they will definitely feel the warmth. And we can tell them that this is due to friction. And also friction as a force, a ball, if we roll it on a floor, we can ask them to roll a ball on a floor, or think of experiences when they have done so. If they have kicked a football, does it keep on moving always, forever, or does it come to a stop? So even if there is no other person at the other end kicking the ball or stopping it by some, by applying a force or any other way, like for keeping an object, or if there is no wall at the other end, even then the ball doesn't keep rolling forever. After some time, it does come to a stop. So we can ask them as to why do you think it comes to a stop? And then gradually we will have to introduce the concept of friction that exists, and the force responsible for changing the state of motion of objects when they are rolling or when they are being pushed against one another is a very good example of frictional force. The force of friction, we need to explain to them that it is always opposite to the direction of motion. And then we can ask them examples of such force, friction. So then we can sometimes we can ask them simple activities to be conducted where they can roll a ball on the table, on the floor, and we can ask them to put their handkerchief and roll the they'll need a smaller ball to roll it, and see how different surfaces provide different kinds of friction. And then we go on to non-contact forces. For non-contact forces, the magnetic forces, we have very interesting activities that children can do with magnets. One is the one which is in the textbook, where we have pencils on a table and a magnet on it. And if you bring another magnet close to it And then we see whether it is rolling away or towards the magnet. Actually, since we are not going to school, I don't have access to bar magnets. Otherwise, we could have seen it also. You can see how objects, how a magnet influences another magnet, and how they move together, or they come in close together or move away from one another. And then electric force, or rather electrostatic forces. Electrostatic forces, again, we can ask them to bring a balloon to class, and ask them to blow the balloon. And since we'll have many of them bringing balloons, so we can group them together again and conduct the activity. We can ask them to rub the balloon on hair, and it acquires static electricity, and bring the balloon next to bits of paper, or we can hang two balloons which have been rubbed against hair near each other, and we will see how they will repel one another. So that's a very interesting experiment that can be done in the classroom. We can use a long ruler and tie the balloons at the two ends and watch them just move away from one another, and explain non-contact force, which affect even from a distance, and then talk to them about gravity. As one of our teachers has said, that we also explain to them about gravity. So we can also use the plastic ruler to help them to understand concepts of electrostatic forces of attraction and gravitational force. We also we always talk to them about objects falling because of the force of gravity, and we need to tell them that gravity acts on all on all objects around us. And one of the reasons why liquids fall down, why water begins to flow towards the ground, because when we open the tap, it just falls down. We famously know of the apple falling, and the concept of gravity. And what we need to tell children is that, okay, I'll come to this a little later, that gravity is not a property of the earth alone. This is something that we will have to explain to children. Every object in the universe, whether it is big and small, applies or exerts a force on every other object. Now, this is something that requires a bit of time for them to understand, that we all sort of exert forces of attraction on one another, and this force is known as the gravitational force. In fact, we need to tell children that the earth attracts us, and we also do attract the earth right back. But the fact that we don't see the earth coming up to meet us, unlike other objects going towards the earth, because gravity has got a lot to do with the mass. So we need to tell children that since the earth is a very, very big object, and compared to what we are, it is impossible for us to make the earth come towards us. So that is one concept that children find very interesting to know, that everything around is exerting a force of attraction on one another. And then here, children, teachers, this is a very simple activity which will help them to understand how how forces are act. So this is a fun activity which kind of, after all the things that we have told them about forces, we can ask them to make these jack in the box kind of activity, where they make a small paper box, and they have, like, here, Merry Christmas. It could be a Diwali wish also, where you could have a lamp here. And when you open the box, this paper has been, it is folded in a particular way in which it emulates a box, a spring. Have you seen this? Have you done this activity, teachers? Or have you made a spring like this when you were younger?
Yes, ma'am. Yes.
Do you remember how you made it?
Yes, ma'am.
The paper spring. Okay. So we can take two strips of paper at right angles to one another and fold them upon its one of them. Okay. So basically, if I have two strips of paper, I will keep them at right angles to one another. I do need to glue them together here. and then I fold it. One fold this side and another this side. And then
Ma'am,
again,
with coconut leaf also we make.
sorry, ma'am.
Coconut leaf. With
Yes,
that also,
yes. That
like
is a very,
snake.
very, yes. I was just about to say that. Thank you for pointing that out, because art is more, I will be talking to you about how we integrate art into our lessons, and that using local materials is always more beneficial for the child. So as I'm speaking, I'm also working on my spring, and I finally have one. I'm sure many of you would have done it. So we have this spring. So if we glue the ends together, since I don't have the glue, if we glue the ends together, we have a spring. So we attach a face to it and put it in a box. And when we open the box, automatically this springs up. So if the paper is a little harder, the effect is really good. So we can ask children to make make a box like this and tell them about a spring. So we can also ask them, because some of them use ballpoint pens, and many of the ballpoint pens have a spring in their, in their, around their refill. I think all of us have seen that. So we can tell them, we can ask them to take out the spring and press down on it and just leave it to observe how the spring behaves. So much of physics can be understood from our day-to-day articles around us. So let us try to incorporate those examples and ideas where the child can learn easily from things around them. So this is an activity which we can ask children to do as a part of understanding of a spring. Of course, a spring there is a lot of other learning behind it with Hooke's law and so on and so forth. But right now in this chapter, we don't need to go into the intricacies of that. We will just tell them that the spring can exert a spring when compressed and left can exert a force. So, and they can do an activity based on that. And then we move on to the concept of pressure. Okay, so to introduce the concept of pressure, we again have to talk to them. We have already given them a very good idea of force. Now we need to talk to them about how force exerted over a particular area translates into pressure. So this is something that is done easily if we give them examples from day-to-day life. Just a minute, teachers. Okay. Give me a moment, teachers. So now this is an activity to explain pressure exerted by liquids, but I would like to first give me a moment, please. So force, we talk to them by giving some examples from day-to-day life, where we can give an example of a nail. When a nail is hammered into a piece of wood, then we can always easily do it if the sharp end of the nail is against the block of wood. But if we do the opposite, or not even a block of wood, we can ask children their experience of putting a board pin into the soft board, which is usually there in every classroom. So we can always ask them to think of why, we always put our thumb against the broader area and push it into the soft board, and that helps us to do the work. But for some reason, if the head of the pin is broken or if it is blunt, then it is very difficult to push the slide, to push the pin into the soft board. So that can give an idea of pressure, how pressure increases when the area of application of the force becomes lesser. So again, like one of our teachers told us, we can talk to them about the relationship of increasing of one of the factors and the decrease of the other one, where inversely proportional. Okay, so are you able to see my screen, teachers?
Yes, ma'am.
Okay, so in order to understand whether they have understood the topic clearly or not, we can give them a simple example of or a simple question, like two rods of the same weight and equal length have different thickness. They are held vertically on the surface of sand as shown in the figure. Which one of them will sink more and why? So do you think this will help children to understand more about pressure by giving an numeric, not a numerical, it's rather a situation. So which one do you think will have more pressure when they have the same weight and equal length? So obviously the one which is thicker would have less pressure acting and will sink less. So this can also be used to understand with the help of some other activities. For example, walking on the sea beach. When a person walks on the sea beach, you really sink into the sand. But if you lie down on the sea beach, you don't really sink into the sand. So if they have been to a beach, we can always draw example from there and ask them to think. So that helps children to understand more about pressure. So pressure
and that is the pressure and the thrust.
yes. Yes, ma'am. What other examples can we give, teachers? What other examples from daily life can we give? One is a pin or a nail. What other examples are very easy ones from daily life that we can give to children so that they understand the concept of pressure easily? I'm not able to hear you very well. Would you please repeat? We can talk to them about how it is easier to cut a fruit with a sharp knife, but we can't cut a fruit by the side of a spoon because a spoon's edge is blunt. So that also gives us a good idea of pressure. We can also ask them, why does your old sharpener not sharpen your pencil properly? So, and try and ask them to think about it and give us an answer. So again, it is because the blade has become blunt. So in order to cut the pencil very easily, if the pressure is more, it will be easier to cut. Then we can also give the example of various hawkers and coolies who take load on their head, and they always keep a turban, a cloth piece which they turn into a circular shape and keep it on their head and then rest the weight on their head, because that will again decrease the pressure on their heads and make it easier for them to carry the load. So this is another concept of pressure that is easily given to children. And then so why do we need to know about water pressure? Okay, one of the reasons you will be seeing is we do need to have some application and knowledge of water pressure, because the plumbing in our houses, sometimes when because water is stored overhead in tanks in most of our buildings.
Yes.
So here water pressure plays a role in having water reach every tap that is there in the building. Okay, besides that, divers also need to be aware of pressure. Now this is something that is not directly allied to the book, but this is some additional knowledge that we can give children. Are you able to view my screen, teachers?
And also it helps to explain how the boats or ships floating in the water.
Yes. Yes, but that is more about upthrust or buoyancy. The principles of flotation. Water pressure is more relevant when we are diving into a pool. So when people who dive into pools, they need to be careful about how deep they go, because the water around us gives an extra pressure. And submarines, which go very deep into the water, they have to be designed carefully to handle the enormous water pressure that is present in the very depths. Yes, ma'am.
We have to apply the force.
Yes.
Then the uppress force.
Yes, the upthrust. Yes, correct. So submarines also have to be very strong. So at the bottom of the ocean, the pressure is equivalent to an elephant standing on your finger. So it's a tremendous amount of pressure which we will not be able to handle. So submarines which go very deep have to be built in a very strong manner so that they can withstand the pressure. And interestingly, there are some deep sea creatures which survive under high water pressure. So this is something which is a marvel of nature. And here what you see is a fish which is called a murderer in the dark. It's an angler fish. And it eats other fish by luring them or tempting them with this. Can you see this antenna on the top which is glowing?
No, ma'am.
Yes, ma'am.
The picture.
Here, ma'am, can you see the picture?
Yeah, ma'am.
Yeah. So I'll try to go for a slideshow, but every time I try to, make it full screen, somehow, it takes me to the video. Here, can you see this? I think it's a little better now.
Yes, ma'am.
Yes. So this very, very strange looking animal lives in extreme depths of the ocean, and it is actually it is called an angler fish, which eats other fish in that area, and it tempts other fish with the help of this antenna. And what is this antenna? It is nothing but a collection of some bioluminescent bacteria. So the deep sea creatures identify their food by looking out for glowing bacteria which latch on organic matter. So basically other fish understand that this is bacteria and come towards it for food. And that is when this angler fish can catch those fish. So it's a mechanism to thrive under the deep waters. In fact, there are some mammals. We are not capable of going deep into the sea, but there are some whales which can dive deep into the sea and remain there for some time. So they have special modifications in their bodies to withstand the enormous pressure that the column of water exerts on them. Because in our cases, if that happens, then we would be crushed by that pressure. And our lungs would not be able to, we would not be able to breathe. So pressure in liquids definitely plays a role in our lives. And then we also have pressure exerted by gases. So these are some examples of where we have tubes filled with gas, balloons, and some speedboats which are filled by by gases which are used in water sports. So pressure exerted by gases, and that takes us to atmospheric pressure. So the molecules of air above us contribute to the pressure at a particular sea level. So depending upon the height of a place, pressure changes, air pressure changes. And air pressure is nothing but the weight of air column which is above a unit area. So while teaching this concept, I have often found that children find it difficult to understand what is unit area. So we need to describe and make them understand that unit is nothing but one, and area is always length into breadth. So 1 centimeter into 1 centimeter or 1 inch into 1 inch is unit area, and the pressure above it exerted by the column of air which is invisible is air pressure. And then we have the very significant contribution of Otto van Guericke, we can talk about scientists to our children. Otto van Guericke was a German scientist, and he had a lot of contributions to science, the vacuum pump, the measuring of weight of air. And as you can see, I have enlisted them, and out of them, air pushes on everything with a powerful force. So we can ask our children to learn more about Otto van Guericke. We can give it as an activity, because nowadays children have, after the pandemic, they have become more familiar with using search engines. So they can read more about Otto van Guericke and give us, we could have we can ask them to write or collect pictures and stick them on an A4 sheet or a chart paper, and we can have it on the walls of the classroom, where children are more familiar with scientists and their significant contributions. So Otto von Guericke, in fact, historic experiment where he could first use a vacuum pump to make an airtight hemispheres. So these hemispheres are locked together with wax and a leather seal, and a pump was used to remove the air. So this is what it looked like. And then a team of 8 horses attached on either side of the sphere could not pull this sphere apart because of the tremendous atmospheric pressure. If that sounds unbelievable to children, we can give them this experiment, which will help them to understand the power of air pressure. So here, let me take you quickly through it, because we are almost approaching 1 o'clock. We have a raw potato and a plastic drinking straw. That is all we need for them to understand the the power of air pressure. Now, if we just need to hold the straw without blocking the hole at the top and stab the potato with the straw. And can you pierce it? Then stab the potato with the straw again, but this time make sure to block the hole with the thumb. So instead of looking at this I have included so that it stays here. I think you could rather, and these are the applications of atmospheric pressure. We can talk to them about sucker and how we can use a straw. When we suck with a straw, this is again atmospheric pressure, which helps us to bring the liquid up to us. I'm stopping my share because I would like to show you what I was talking about, the potato experiment. So I have a potato and a straw. I suggest all of you to get hold of a straw. A potato is something we all have, and try it at home. Even I was surprised by how quickly it works and how well it works. So here I have the straw with open ends, as you can see. And I'll try to put it into the potato. And well, I can tell you that, well, this is all it went. Not much, as you can see. Okay. Now I do something very simple. I just block the top of the straw with my finger. And I have the same potato and I apply the force. Okay, so I'll block it with the finger. Sorry, I'll block it with the finger and apply. And do you see how easily it goes in? Okay, I'll do it again. Block the top. Teachers, please do it. You will be able to understand it for yourself, because when you see me, you probably might be thinking that I'm exerting more force when I'm blocking the arrow on the straw on top. I just block it and I put it and it goes right in. But when I take it out and I try to do it with the straw open, you see I'm not having much success. Okay. Now, can you explain this? I'll do it again. Here. It's air pressure at work. When we have the straw which is open on both ends, when we use it to push it into the potato, it takes a lot of force, because as the straw comes on the surface of the potato, air rushes out of the open end. On the other hand, when I close the tip of the straw, I have a column of air trapped inside the straw. And then when I push it, it goes right in, because the pressure exerted by this column of air trapped inside the straw makes it easy for me to do the work. So this is the power of air, just a column of air trapped inside the straw. So this is something which is very effective for young minds to understand the concept of air pressure.